Alright, so today I'm gonna talk about fire and fire simulations, and also I will tell you about volume light. So it's basically a light which is simulated from your pyro simulation, and this will look something like this. So here's an example. It's just a basic preset, but you can see that light is just wiggling a bit according to flame. So I will show you how to do this, and also I will talk about this noise and how to avoid it. And basically I want to cover the parameters of the flames and the FireFX here in Houdini, so you will get the understanding of how it works. So let's get started. Let's begin talk about FireFX in Houdini, and all of them are placed in the FireFX tab here on top. We have a few presets here: flames, explosion, fireball, billowy smoke, wispy smoke, candle, smokeless flame, dry ice, volcano, smoke cluster, and pyro cluster. Well, those few are basically the same, they just have a different settings. This too is a bit different, and volcano is also similar to flames, but just designed for a huge scale. Alright, so let's get started. First we need to create some object which will be burned, and let's create a sphere, just a simple sphere. And to apply the settings, the preset, we need to select the sphere and then just click on any of them. So I will click on the flames. It calculates a bit, which is fine, and then it will be turned into this. Alright, this box is basically a pyro container. The whole simulation will be happened inside of this box. If something will try to go outside of this box, it will be clamped, and you will see the flat simulation here. So this will be like a slicing box. Until it's inside, everything is fine. Okay, let's play simulation. It plays in real time, which is pretty nice. Okay. And here I have smoke, which is barely visible for you and for me too. So to make it more visible, I will hit D on the keyboard, and this will open the display options, or I can click here on this eye. And this opens a display options window, where we have control about how it looks. And we are looking for background tab, and let's change a color scheme to dark from light. Alright, so now I can see my my smoke better. Okay, this gray one. Alright, and currently this simulation doesn't have any affecting force or something that will affect its behavior. And the resolution of this simulation is pretty low. That's why it plays so fast, but it's possible to see it's almost possible to see the voxels here. Alright, so you see that it's blocky and it's almost voxel around here. Alright, but it's fine for now. And first I want to talk about parameters which are affecting the simulation. I will click on two-dimensional. This will make a plane with my simulation instead of 3D, but this is fine for for the purposes, so I can see what's going on. Okay, so first, the most important parameter. Oh, and I'm inside of Autodesk network. So if you're going up to Object Network, here we have a sphere object, Autodesk network, and the import Pyro build. This one was automatically generated after I clicked on Flame preset. So let's go inside Autodesk network, and here we have Pyro node, resize container, and source, and Pyro solver. So solver is basically a calculation place for all calculations which happens about your simulation. So it basically takes input data and calculates it. And the gravity force with Apple. Alright, so Pyro, resize, and source. Alright, let's select a Pyro node. And here I have 2-dimensional and 3-dimensional, which you already saw. Alright, and I can change which direction it works. So for example, if I need something flat on the backside, but with nice simulation, I can set it to 2D and simulate it faster. Because it will be faster just because it's simulating only one voxel thickness, while here it will simulate a lot. So just slice this box to many 2-dimensional slices and you will get 3D. Alright, division size. It basically tells how many the number of voxels which will be fitted in one unit. Alright, so now I have size 7 by 13 by 7, x, y, z. So 13 is height, and 7 and 7. So it's a cube here. And alright. To see how many voxels the simulation has, you can middle mouse button click on the Pyro node, and here we have all the fields which simulation has, and inside of the square brackets you can see 35, 65, 35. It's basically the voxel dimensions, which is 7 divide 0.2. And yeah, 65 is also 13 divided 0.2. And total voxel count is almost 80,000. This is pretty low amount of voxels. And let's see how it's affecting the simulation. So I hit play, and it's real time. So it's playing real time, it's fine. Here we have this real time toggle. So for example, if my machine is super strong and it can calculate the simulation faster than real time, this will look unnatural. So this button here, it will limit the playback speed. So like now, you see it's already cached and it plays too fast. So I hit real time toggle, and now it plays 25 frames per second, and this is how it looks. Okay, so let's stop and rewind. Now I will set my division size to 0.1, and you see that the scale of my, not scale, but the resolution of my simulation is grew up. And instead of 80,000, I have almost 640,000, which is way more. And the simulation time, this is not that fast, but immediately we can see way more details in simulation. So I will create one more sphere, and I will apply the same preset like here, and yeah, now I have two sets of flame. This one is first I've created, and this one is second one. All right, and this one is 0.2, and this one is 0.1. So if I play this, well, even without playing, you can see the quality difference in flame, and yeah, way more detail, and the flame become more interesting and very detailed. But again, 0.1 is pretty low resolution because it doesn't keep all the details which can be here. All right, so I will set both of them to two-dimensional, and we'll set 0.2 to both of them like this. So now it's totally the same, and it's playing fine. I just want to move this sphere a bit so it's not overlapping. And one important thing that you see, I moved my sphere, but my FireFX stayed in place. So to move it, we have a center channel inside of Fire node. So I can move it to, oops, the wrong one. So something like this, and I will move my sphere a bit too. So fine. All right. Two the same spheres, two the same simulations. Okay, let's check what we have more. So again, in a Pyre node, we talk about size, which is container size. I can set it bigger, you see. Okay, and here I have guides tab, where I can check all my fields which are inside of the simulation. So now it's turned on multi-field, but I can turn on density, which is the density field is responsible for smoke. So this is field you can control to do something about the smoke. All right, I have temperature. The temperature controls the ignition process. I will talk about it a bit later. So basically, it's like a threshold for ignition. So if the temperature is lower than ignition temperature, the simulation will not start. Fuel. The flame basically needs something to burn. So here you can see we have a fuel which is burned. And I can paint my own fuel, for example, texture or something, and this will burn it. Divergence is basically how the flame is expanded. Burn, heat. Alright, so velocity. Velocity basically tells in which direction the force is applied. So now I have no force applied, so there is no velocity. Collision, it's shows what it collides with, and source, sink. Well, sink is where the simulation is syncing off, so it's just decreasing here. So I will turn on multi-field. Okay, but here we have a lot of control about viewport, how it looks in viewport. So if I go to multi-tab here, so this tabs is controlling this field. So I'm going to multi, and here I can change density scale and shadow scale. So for example, if I increase density, the simulation becomes more visible. All right. But this is not affecting the simulation by itself. Okay. And for example, if I bring it back to 3D dimensional, like this, and you see it, the calculation is way slower than in 2D. All right. Currently, there is no shadow in the scene because there is no light. So if I create a spotlight, and let's say I will bring it somewhere here, I should be able to get the shadows on my simulation. So yeah. So you see the light is affecting the viewport representation. So if I set my densities too high and shadows too high, the simulation will look like this. So it happens because the data is inside of this field, inside of this box, but on normal density and normal shadow scale, the data which is, for example, placed here is so settled so the Houdini not visualize it. So, all right, and let's bring it back a bit, something like this, to make it more visible, noticeable, and two-dimensional for sake of speed. And I will kill my light here because in 2D I don't need this. Okay, let's go back to Pyro. And density ramp, I can control how it behaves. So something like this. It basically gives you the control about how it looks. All right, let's kill this. And to remove these markers, you have to click and drag to the bottom. So this will delete it. Okay. Initial data fields. Here we can have control about which fields must be in dynamic. Slice. Slice is controlling. Well, it's basically self-describing, but this should work. Strange. Yeah, okay, now it works. So it basically takes the piece of your simulation. So, for example, if you want to know how it looks somewhere, inside of the simulation, you can use this. So, yeah, all right. Next, let's go to creation. And currently, it takes frame number 1, and this value is taken from here. If you go up one level to object level, object network, and select Autodesk network, here we have like a main control panel about the whole simulation. So first I have initial state, so I can simulate up to here, then record it as a file, and then use it as an initial state, so I don't have to wait from beginning to this point each time I do the changes. Okay, the sub-steps is basically control the quality of simulation and how many steps it will take between each frame. So currently it stands number 1. So from frame 1 to 2, it will take 1 sub-step. If I set it to 9, it will split my frame into 9 parts and do 9 calculations in one frame. This is very high, the substeps number, but this might be useful for very precise simulations. For example, if the flame or water or something else must collide with object, and this must be really accurate. And you see how slow it becomes because it calculates a lot. Alright, so let's bring it back to 1. Start frame. This is a number which we saw here, creation frame. So let's say I want to start my simulation from frame 10, like this. Oh, okay, 10, not really visible. Alright, now it hits 100 and starts to simulate. Yeah, like this. And it changed here. If I click this, the simulation will start from here. Alright, let's go back, set it to 1. So offset time calculates automatically. It takes start frame channel data -1 and divided by frames per second. So I can see how it's offset in seconds. And currently my playback speed is 24, which is not correct. So I set it to 1. 25, yeah. Now it should be 4 seconds, but because of -1, it goes here. It goes to 396. Okay, scale time. So let's bring start frame to 1. Scale time. If I play my simulation, let's say up to frame 50. It plays like this. If I set my scale time to 10, this will be like this, and it happens because of very little substeps, so the interpolation is extremely huge. So probably I should set it to 3. Right, and you see the speed of simulation. It's affecting the speed. All right. Next parameter is max feedback loops. It's basically how many steps Houdini will take to equalize two different solvers. The more better description you can find here and in help. But this is kind of advanced stuff because you need to have two different solvers or more, and if you have just one, leave it alone. All right, enable automatic resimulation. It's kind of useful because when you fine-tuning your simulation, you're doing a lot of changes, and when you hit play, this will automatically resimulate your simulation with new parameters. And if you leave it alone, if you turn it off, you will have to reset your simulation each time manually. Interplay display data. It's basically do interpolation. If I turn it off, it's not very visible, but because of low res and pretty simple simulation. But yeah, it's for interpolation. Cache simulation is very dangerous and bad feature. I hate it because it's caching your simulation like now. So I played once and it cached it like this, but now it works fine. But let's imagine that I have my simulation set to something 0.5 and the number of voxels is 5 million, and one file will take really huge space, will take a lot of space in the memory, and this data will be stored inside of your RAM. So now it's caching and it should grow up. So yeah, you see it started growing. And this is just 30 frames in nothing. I mean, the simulation is simple and it's already taking 11 gigs of memory. And normally, until you have the low-res simulation, it's fine to have this feature turned on. But once you turn into something really heavy, it's better to turn it off because it's 45 frames and 13 gigs is eaten up. And let's imagine I have 300 frames with even higher resolution because this res is kind of average and a lot of details is here. Yeah, so it will eat up all your memory and you'll crash. That's not what you want. Alright, so you need to turn this off, reset. Now it takes 11 gigs, but it's not just cleaned up. And let's play. So now you see it doesn't take my memory. It's not caching at all. And the opposite side of this, of turning off this feature, is that after playing it here, I can't click on frame 25 and make it work. Well, there is a solution which is has been shown to me by Jeff Wagner, which is a super guru of Houdini, and the workflow he showed me is just amazing, and it allows to render insanely high quality flames. So, all right, let's turn it off. Let's stop. But I will show this workflow in a minute. So for now, let's leave it turn on. Let's bring my simulation size back to 0.2. All right. So now it's again fast and easy. And compressed scene files, well, scene is a simulation file. This is extension for simulation file, and it stores all the data which is relative to the simulation. It keeps data about temperature, velocity, density, and so on and so on. Cache memory, it tells how much memory it can be used to store your simulation. Allow caching to disk. Well, turning on this feature can help you a bit, but this will take all the data from your C drive because it will record each frame simulation file to the disk, and it's really heavy. All right. Cache substep data is for caching substeps. So if you have 9 substeps, it will create 9 cache files for this, so which is also really heavy. Timeless, no history, and this will like kill the history, so you can't play it again. Explicit cache, well, this one you can create a caching to disk, and this will hook it up once you want to continue your simulation. So for example, if I cache something up to frame 25, 50, and I want to continue this, connect this cache, and this will continue my simulation, which is kind of useful, for example, if you're afraid to crash or something like this. All right. Transform, well, this is for transforming simulation, so I can rotate it, and this will affect the gravity force. So you see the flame goes a bit this way. No, it's not affecting the gravity, it's just global rotation for the whole simulation. All right, let's bring it back to 2D. Next, let's move from Pyro to resize container. And when I'm playing my simulation, so something like this, I have fluid type, fire, smoke. If I change it, so okay, I will leave it as smoke, and let's play with this one. Let's say this one is fire. I will bring it back to default, so the simulation looks the same. That doesn't look the same for now. Which is strange. Multi-field. Yeah, okay, I can take a preset from this one, and I can save a preset. Like this, save, and I can apply my default flame. Yeah, and just doing this. So now it's the same again. That's how you can transfer data from one simulation to another one. All right, and let's go to this resize container. So here I have flame, here I have smoke, and difference, there is no difference. If I set to liquid, then it behaves different. You see, so it just doesn't work because it requires a different set of fields. So I set back to smoke. Extra resize field. For example, you can create your own field which will affecting the resize of this box. And delay frames is specifies the number of frames which before it starts to resize the container. So if I set to 5 or 10 and play, so you see the frame number 1, this one is not changed, and this one is small. All right. Padding. Padding is affecting the firebox the size. So I can set, for example, now it's 0.4, and you see that boundaries is resizing not really fast. But if I set to 2, for example, it's not resizing because padding is already really huge. And to see it, I need to set my firebox bigger. Let's say 15 by 15, like this. So now the firebox is really huge, and I'm playing it, and you see that boundaries of this firebox is coming to the side faster. So it's like a gap between the simulation and the limits of the bounding box. Whoa. All right, and that was padding. Here is the scales of padding. So lower padding. So I can scale it up, and 0.4 will be scaled in this way. Okay, and here is field tab, which is standing as density now, and this field is controlling how the firebox will be expanded. I can set it to something else, let's say heat, and play. And you see it's expanding a bit different because it takes only the heat data, and it works differently. So the heat is decreasing and the box is falling down. The heat one is responsible for actual flame. So you see, and the smoke, which is controlled by density field, is clamped down here. So instead of heat, it's normally you need to use density, which is default value. All right, like now. Max bounce is it's clamping your firebox, and I can turn it off. Okay, from object, for example, from object. So it's clamped to the object size, which is not what we want. Static, it will grow up to the numbers you set in a Pyro node, like this. You can choose dynamic, and this will grow up to object size. Like it's growing. Okay, and it stops. Enforce boundaries. If I turn this off, this the dynamic should allow us to get automatically resized box. So for example, if I change some parameter here like this, it's not growing. Let's clamp. If I turn off clamp, yeah, it's keep growing. So like this. I'm not sure if you can see the smoke, so I will set density to 1 or something like this. So now you see the simulation box is growing up, and here is the situation when I have to increase the padding. So currently my smoke is hitting the wall and clamped, which is not nice, not what I want. And I will set to padding 10, so my box is growing up really fast and is not hitting the limit. Yeah. But again, this makes the simulation slower because Maya has to, not Maya, Houdini have to calculate the whole area here. So you must be really careful about what you're doing, because otherwise you can wait for days of while your simulation is get ready. All right, so I'll bring it back. It was 4.5, I believe. Yep. Okay, that was max bounds. Source is our next node, and here we take our what we're taking from to start our simulation. So we're taking fuel from sphere. I will cover up this in a moment. Here is an activation which can be animated for sure. So now it's not activated, and yeah, okay, I need to animate this. So if I set it to set yeah. Okay, the value is growing up, but nothing happens. That's strange, but activation must work. Yeah, okay, let's leave it as 1. Scale source volume. So this one has number 1. This one will be number 10. So this one used for huge explosions. So if I will try to animate this too. So I hope it works, because when it doesn't work, it makes me feel stupid. and commit change scope parameters. So here is my curve, and let's say on frame 10 this will be something small. Like this. And let's play animation. So yeah, the volume gets smaller, and this is just the side effect of this explosion. Alright, let's delete the channel. Temperature, it works the same way. So if I set temperature high, you see the difference in simulation. And this can be animated too in previous, like a previous value. Scale velocity, well, this one is used for scaling the velocity force, and for example, if I would have wind or something like this, or any other velocity field, I can scale it up, and this will control the scale of my force. Okay, here is volume operation, so you choose what you want to do with your fields. And yeah, here is the field which is used. Alright, and next let's go to FireSolver. It's a place where all simulation happens.